What is DCS? A distributed control system, DCS, is a specially designed automated control system used to control complex, large, and geographically distributed control elements over the plant or control area. A distributed control system provides system redundancy to handle complex processes, predefined function blocks, more sophisticated HMI, scalable platform, system security. In DCS, each process element or machine or group of machines is controlled by a dedicated controller. DCS consists of a large number of local controllers in various sections of plant control area and are connected via a high-speed communication network. These controllers are able to communicate among themselves and also with other controllers like supervisory terminals, operator terminals, historians, etc. Distributed individual automatic controllers are connected to field devices, such as sensors and actuators. These controllers ensure the sharing of gathered data to other hierarchical controllers via different field buses. Different field buses or standard communication protocols are used for establishing the communication between the controllers. Some of these include Profibus, Ethernet, fiber optics, HART, ArcNet, Modbus, and etc. In picture we can see there are different protocols are used for data transmission. Fiber optic, Profibus, Ethernet. Detail of each media will be studied in future videos. DCS is most suited for large-scale processing or manufacturing plants wherein a large number of continuous control loops are to be monitored and controlled. The main advantage of dividing control tasks for distributed controllers is that if any part of DCS fails, the plant can continue to operate irrespective of failed section. Because in DCS mostly devices are redundant. Redundancy in a system means if one device or network fails, its second device or network takes control of the system. On redundancy, we will talk in future videos. We can divide the architecture of DCS in multi-levels. Field level contains the field devices such as flow and temperature sensors, valves, actuators, and etc. At this level sensors measure the physical quantity and converts the signal into electrical form via transmitter and send the signal to controller. Controller level controls the inputs/outputs according to the instructions stored in controller. Plant supervisory level contains the supervisory computers, which collect information from processor nodes on the system, and provide the operator control screens. Data logging level and engineering level. This level contains the supercomputers means servers, which are used to log data, historian, and to perform engineering tasks. Each DCS have some basic components or elements, which are engineering workstation, used for programming, troubleshooting, and modification of the programming. Operating station or HMI, used to view and controlling of process control unit of DCS. It includes controller, field devices, and etc. Communication system. Backbone of any control system, it's a way of communication between devices. Smart or intelligent devices. There are multi-DCS providers are available in the world. Some of them are Yakugawa. Its DCS name is Centum VP. Delta V, Ovation by Emerson. EcoStructure Foxborough by Schneider. PCS 7 by Siemens. DNA by Metso, Valmet. System 800XA, Symphony Plus by ABB. Plant PX by Rockwell. PMSX Pro by Mitsubishi. Mark V by GE. X Bryan by Honeywell. ECS by FL Smith. Distributed control systems are dedicated systems used in manufacturing processes that are continuous or batch-oriented. Processes where a DCS is using include chemical plants, petrochemical, oil, and refineries, pulp and paper mills, boiler controls and power plant systems, nuclear power plants, environmental control systems, water management systems, metal and mines. Automobile manufacturing, pharmaceutical manufacturing, sugar refining plants, agriculture applications, environmental management systems, water treatment plants, sewage treatment plants, food and food processing, agrochemical and fertilizer. There are many advantages using DCS, some of them are: failure of one unit doesn't affect the entire plant. Redundancy is available at various levels. Instruments and interlocks are created by software. Field wiring is considerably less. Cost-effective in large. Safe operation of plant. Lowest cost of generation. Longest equipment life. Minimum environmental effect. High reliability. Improved response time. Improve operator interface to plant. Historian. So guys, this is a basic overview of DCS. For more informative videos, follow us on YouTube. Thanks for watching.